first question is a use of calculator question. To answer this question, make sure you start with the square root button and put your fraction inside of the square root. Make sure that your 25 and your 40 are in brackets and your 25 and your 40 are in brackets. The answer you should have got was 2.9111. You needed at least 3 or 4 decimal places to get this answer. For question 2, we've been given 2 ratios. We know that the total number of cows to sheep are in the ratio 6 to 5, and we've been told that the ratio of sheep to pigs is 2 to 1. We've been told the total number of cows, sheep and pigs on the farm is 189, so we need to split that 189 into our cows, sheep and pigs ratio. This ratio is not together at the moment, so we need to combine this ratio. We can see the lowest common multiple of 5 and 2 is 10, so if I multiply my second ratio by 5, we get 10 to 5, and my first ratio by 2 is 12 to 10. This means that cows to sheep to pigs can be written in the ratio 12 to 10 to 5. I can then split my 189 animals into those 27 parts. This gives me 7 for each. It wants to know how many sheep there are on the farm, so we do 7 times 10 to give us 70, so there are 70 sheep on the farm in total. Question 3, this question you need to read carefully. Kira used her calculator to work out the value of a number. She wrote down the first 2 digits on her calculator. She wrote down 7.3. Now, we're used to the error interval being slightly above and slightly below the answer we've been given, but this time we're truncating, which means we're looking at the first 2 numbers. So 7.3 is the smallest value we could see on her calculator. The largest value we could have seen on her calculator is 7.39 reoccurring, but the question wants a value that is an upper limit without being equal to. So you can write 7.39 reoccurring, or you can write 7.4. Question 4, we know that 20 students study both French and Spanish, so 20 go in the middle. 13 students study French but not Spanish. That means 13 students go on that left-hand side. It says a total of 43 students study Spanish, so the Spanish circle must be 43, meaning there's 23 left over for Spanish. If we add those values together, we end up with 56, and there are 60 students in the college altogether, so that means there's 4 on the outside. Part B says one of the students is selected at random. We know that that means this probability will be out of 60 because we're selected from all of the students. And it says write down the probability the student studies neither French nor Spanish. We have 4 on the outside, so 4 out of 60. You can simplify this, but you don't have to. Question 5 is question our indices rules. It wants us to work out the value of y. Very common on calculator papers that they won't ask you to just do some simplification, but might work backwards slightly. So 7 to the power of 2 to the power of y is the same as 7 to the power of 2 times y. We know that that must be 10, so the value of y is 5. Part B is a slightly tricky question. It's not asking you to work out the value of n, but 3 to the power of minus n we know is the same as saying 1 over 3 to the power of n. This is the same as 0.2, and we can write 0.2 as a fifth, because a fifth is 0.2. This means we know that 3 to the power of n must be equal to 5 if we compare these two. The question wants the value of 3 to the power of n squared, which is the same as asking for the value of 5 squared, and this is 25. Part C, we've been given that 100 to the power of a times 1000 to the power of b is equal to something in the form of 10 to the power of. This is a change in the base question. I can write 100 as 10 squared to the power of a. I can write 1000 as 10 cubed to the power of b, and that is still equal to 10 to the w. Using my indices rules, we end up with 10 to the 2a times 10 to the 3b is equal to 10 to the w, and again with indices rules, this is the same as saying 10 to the 2a plus 3b. I can then say, therefore, 2a plus 3b is equal to w. Very important you show all of your steps here because it gave you the answer, and as it's a show that question, they'll want to see you're working all the way through. Question 6. We've been told that triangle A is reflected, it's then reflected again, and it wants a transformation from the first to the final triangle. You will always pick up method marks for doing the transformations. So if I'm reflecting in the x-axis, this is our x-axis, so I can reflect my triangle over. And I can label this triangle B. It then says triangle B is reflected in the line x equals 1. My line x equals 1 is the line that goes through x is 1 here, so I can reflect my triangle in this line. And this is my triangle C. The question wants you to describe fully the single transformation that maps triangle A onto triangle C. There are two different answers for this. You could have had a rotation of 180 degrees about the point 10, or you could have had an enlargement with a negative scale factor of -1 from the centre 1, 0. I would have chosen the rotation because it's easier for me to see that it's a rotation, but only use one transformation, otherwise you will lose all of the marks. So you get a mark for rotation of 180 degrees, and then the coordinate is 1, 0. Again, the other answer was an enlargement by a scale factor of -1, and the centre again was 1, 0. Question 7 is a tricky currency exchange question. We need to find two comparable values. I'm going to start with the fact that we know that in London we can have £1 of potatoes costing us 45 pence. If I multiply this by 1.15, that will tell me what £1 of potatoes is worth in euros. That comes out at 51 cents and a little bit. It doesn't matter that this isn't correct in terms of money because we're using this to compare to another value. In Dublin, we know that 1 kilogram of potatoes costs £1.48. Okay, now I already have my pound of potatoes in euros, so I'm going to change the kilogram into pounds so that I can compare. I know that 1 kilogram is 2.2 pounds, so I'm going to divide this by 2.2 because that will then tell me what £1 is. So this will be £1 but in euros. 1.48 divided by 2.2 gives me 0.673 and so on. I can see from here that a pound of potatoes in London costs about 52 cents, but a pound of potatoes in Dublin costs about 67 cents. So I can say that London is cheaper. We must put that conclusion comment at the end. London is cheaper. There were lots of ways to do this. That's just the way that I chose. You could compare kilograms or pounds in either pounds or euros. Question 8 is a question combining algebra and geometry. These questions are quite common. The area of the shape is given as A, and it wants us to write a formula for A in terms of x. We can split this shape up. I'm going to split this shape up across here, but we could go down instead. This length at the top is already labelled as 2x. As the length on the left hand side is 2x plus 3, and the right hand side is x plus 3, I know that this length here must be x. Finding the area, we multiply the sides. The area of this rectangle is 2x squared, and the area of this rectangle is 7x plus minus 2 multiplied by x plus 3. If I expand this out, I'm going to get 7x squared minus 2x plus 21x minus 6, and that will simplify to 7x squared plus 19x minus 6. The two areas together, I have 7x squared plus 19x minus 6, and the area at the top is 2x squared. It wants a formula for A, so A, when I collect the like terms together, we get 9x squared plus 19x minus 6 as our answer. A formula, you need A equals for your formula. not just the answer. The next question is about similar shapes. We've been told that trapeziums are mathematically similar, meaning that we can work out the scale factor of how we go from 12 to 18. You can do that by dividing 18 by 12, which gives us 1.5. So the scale factor from one trapezium to another is 1.5. It wants us to work out the length of AB. We know the length of AE is 5, so we just do 5 multiplied by 1.5, which gives us an answer of 7.5. The next question says the trapezium has an area of 36. Work out the area of the shaded region. If my scale factor for my length is 1.5, it means my scale factor for my area is going to be 1.5 squared. If I multiply those together, 36 times 1.5 squared, we end up with an area of 81. Now that's the area of the trapezium ABCD. It only wants the area of the shaded region, so we must do the area of the entire trapezium, take away the area of the small trapezium, and we end up with an answer of 45 centimetres squared. Question 10 is finding the volume of two shapes that are put together. We've been given the equation for the volume of the cone and the volume of the sphere. The answer wants it in terms of pi, so we're going to keep pi in our answer rather than typing the whole volume in our calculator. At the volume of the shape, we have the cone. We've been given the volume is a third times pi times the radius squared times by the height, and then we're going to add on the volume of the hemisphere. We only have half of the sphere, so it's half multiplied by the volume of the sphere, which is 4/3 times pi times our radius cubed. I can simplify this. A third times 9 times 10, that gives us 30. So the volume of the cone is 30 pi. And then a half times 4/3 times 3 cubed is going to give us 18 pi. When I put these together, we end up with 48 pi, so our value of k is 48. Question 11, this is a capture-recapture question. We know that on the first day he catches 80 termites and he puts a mark on each of those and puts them back into the nest. And the next day he catches 60 termites, but only 12 have a mark on them. We're working under the assumption that only 12 out of 60, this fraction, this proportion of the termites have marks on them, and we know that that is equal to 80 over something. This is the amount that have marks on them, and the 80 is the amount that Toga puts marks on. Okay, so we need to work out what this is equivalent to. So going from 12 to 80 is multiplying by 6.6 reoccurring. So we times this by 60 and we end up with 400. So in total, he's found 400 termites. The assumption that we made, this will get you another mark. We've assumed something like the population hasn't changed, the marks don't wear off, the sample is random. The normal one that people put down is that the marks have not worn off. Or sometimes it's the tags have not fallen off, or the tags haven't been removed. Question 12, x is directly proportional to w squared, and we've also been told another formula where one is inversely proportional to another. It says x is directly proportional to w squared, so we can write that x is equal to kw squared, and we can use the values of w and x to work out what k is. So 48 is equal to k multiplied by 4 squared. So 48 is equal to 16k, and we can do 48 divided by 16 to find out our value of k, and we know that k is 3. We can then write our formula as x is equal to 3w squared. I'm then going to have a look at my inverse proportion. So it says that y is inversely proportional to x cubed, meaning we can write y is equal to k over x cubed. I'm going to do the same thing again. Y is 14 when x is 2. So I can say that 14 is equal to k over 8. And then I can work out my value of k by doing 14 multiplied by 8. This gives us a value of k as 112. I can write my formula out again. Y is equal to 112 over x cubed. I now have two formulas, one for x in terms of w and one for y in terms of x. The question wants a formula for y in terms of w, so we need to say y is equal to something. We know that y is equal to 112 over x cubed, and we also know that x is 3w squared. So I'm going to replace x with 3w squared, so the denominator of my fraction is 3w squared cubed. To simplify that, we end up with y is equal to 112 divided by 3 cubed is 27, and w squared cubed is w to the 6. Question 13 is an interpreting data question. We want to work out the interquartile range of the information from the box plot. The interquartile range we get from taking the upper quartile and subtracting the lower quartile. So our upper quartile here is 188, and our lower quartile here is 50. So we need to do 188, take away 50 to give us 138. The next question says 50% of people waited for at least 2 hours. Is Becky correct? Explain why. We know 2 hours is 120 minutes and our median is spot on 120 minutes. So yes, Becky is correct because the median is 2 hours. It's a 1 mark question, that's enough. The second half shows us some information from our hospital on Tuesday. I'm just going to write down some of Monday's information. So the median was 120. We knew the lower quartile was 50 and the upper quartile was 188. Becky compared these and said people had to wait longer on Tuesday than on Monday. Give one reason why Becky might be wrong. She might be wrong because on Monday the median was higher, so on Monday people had to wait longer. The median on Monday was higher. You could have also talked about an outlier where there might only have been one person waiting 210 minutes. You could have said we don't know how long people were waiting between the times, or you could have said that the upper quartile was lower on Tuesday and higher on Monday as well. Question 14 asks us to prove that two lines are parallel. We know lines are parallel if they have the same gradient. So we've been given a triangle P, Q and R, and we've been given the coordinates. So I'm just going to sketch this out. We could have P having the coordinates -3, -6. We can then have Q having the coordinates 1, 4. And then we can have R having the coordinates 5, -2. Okay. M is the midpoint of PQ. And N is the midpoint of QR. Okay, it wants to know about MN and it wants to know about PR. We can work out the coordinate of M. So M is the midpoint of P and Q. So our coordinate for M is -1, -1. And our coordinate for N, being the midpoint of Q and R, is 3, 1. So to prove they're parallel, we want to work out the gradient of MN. So the gradient of MN is our difference in our y coordinates. Our difference in our y coordinates is 2, divided by our difference in our x coordinates, which is 4. So the gradient is 1/2. For PR, we do the same. The difference in our y coordinates from P to R is 4, and the difference in our x coordinates is 8. This also simplifies to 1/2, so we can show that they are parallel because they have the same gradients. Question 15 is using the sine rule. It wants us to work out the area of the triangle. To work out the area of the triangle, we want to use a half AB sine C. The problem with this is we've only been given one side. We've just been given the side AC, and we need to work out what the length of the side CB is. So we know that CB we can work out using the sine rule. I can do this because I have a matching pair here, but I just need my other matching pair. We know that angles in a triangle add up to 180, so I can work out that the angle in this triangle here is 35. To work out what CB is, we can do that side over sine 35 is equal to 6 over sine 25. If we multiply 6 over sine 25 by sine 35, we end up with CB as a length of 8.1431. Keep this value in your calculator when you're working out the area. So our area is a half multiplied by either side of the angle multiplied by sine 120, and we end up with an answer here of 21.2. Question 16, sketch the graph of cos of x. Cos starts at 1 and it finishes at -1, and it goes through points at 90 and 270. This must be a smooth curve as best you can, through 90, the minimum point at 180, and back to the maximum at 360. The most common mistake people forget is forgetting to label our axes at 1 and -1. The second part of question 16 is a graph transformations question. It wants us to sketch the graph of 2f of x. This affects our y-axes, our y-coordinates, and it multiplies our y-coordinates by 2. I can take some key points. So for example, the coordinate -3, 1 will now become -3, 2. The coordinate -2, 1 will now become -2, 2. The top point at 0, 3 will now go to 0, 6, and similar to the other side. Our x coordinates stay the same, but we can draw this new graph in. The second part of this has a transformation of x -3. This affects the x-axis, and it adds 3 to all of my x coordinates. So the point that's currently at -3, 1 will go to 0, 1. Our maximum point from 0, 3 will go to 3, 3. And then similar on the other side. And our graph should look like this. Question 17 is a functions question. We've been given two functions. The first one wants us to find the value of f of 10. So f of 10, we substitute 10 instead of x. This gives us 3 lots of 6, which is 18. The second question wants us to find an inverse function. We've been given the function g of x, so I'm going to call this y is equal to x over 5 plus 1. I'm going to rearrange this to find x equals. So we have y minus 1 is equal to x over 5. Multiply this by 5 to give me 5 y minus 1 is equal to x. So our inverse function is 5 x minus 1. Part C is another show that question. We must show our working very clearly. It's a composite function of f of x. So f of x is 3 lots of f of x minus 4. This is 3 lots of 3 lots of x minus 4 minus 4. If I simplify the inside of this big bracket, we end up with 3 lots of 3x minus 12 minus 4, which is the same as 3 lots of 3x minus 16. And we should see when we multiply this out, we end up with 9x minus 48. Question 18 is solving a quadratic inequality. We've been given that x squared is greater than 3 lots of x plus 6. I can multiply this out to get 3x plus 18. To solve a quadratic inequality, the same as a quadratic equation, we need this to be equal to 0, so I'm going to subtract 3x and subtract 18. I can then solve this. I can either factorise it or use the quadratic formula. This factorises quite nicely to x minus 6 and x plus 3. So I know that my solutions are x is 6 and x is minus 3. Sketching this on a graph, if I'm going through minus 3 and 6, so label this as 6 and minus 3, I want all of my values where it's greater than. So I want all of my values that are above the x-axis. This is when x is smaller than minus 3 and where x is bigger than 6. Question 19 is a percentage question. Part of this is working backwards, so we're going to write down the information that we know. So Katie originally invests £2,000, and in the first year she gets 2.5% interest. After the first year, that gives her £2,050. It then says she gets X% for the second and third year. So we know in the second and third year we are multiplying by 1 plus our percentage to the power of 2. It tells us there's a total amount of £2,124.46 at the end of the 3 years. We need to work out what that percentage multiplier is, what that value of x is. So I can tell you that 1 plus x over 100 squared is equal to 2,124.46 divided by 2,050. We can then square root this answer. If we square root this answer, we end up with 1 plus x over 100 is 1.01799, which should show us that x is equal to 1.799%, or 1.8% will do. The final question is a circle theorem's proof question. It is not enough to state the circle theorem, it's asking you to prove that the angle at the centre is double the angle at circumference. The first step of most circle theorem questions is to create a new radius from the centre to another point on the edge of the circle, and this creates isosceles triangles in our circle. We can label the angle at the top x. As this is an isosceles triangle, we know that this is also x, and that makes our angle AOB 180 minus 2x. We can label here, it's because we have an isosceles triangle. I can do the same on the other side, label the two angles y, and in the centre we have 180 minus 2y. We also know that angles around a point are 360. So we can say that the angle BOC is 360, take away the other two angles. Okay, we can see that that simplifies to 360, take away 360 minus 2x minus 2y, which gives us angle BOC as just 2x plus 2y. We've labelled angle BAC already as x plus y, and then we can say that this is proved. Angle BOC is double angle BAC. The next question is another proof question. This time we have to find an equation for cos of PBQ. PBQ, if I draw a line from P to B and B to Q, cos of that angle is the angle here. We know we're going to have to use the cosine rule, and we can see from the cosine rule that PQ squared is going to be equal to PB squared plus BQ squared minus 2 times PB times PQ times by cos of our angle, which is PBQ. I know what PB and BQ are. PQ squared is going to be 10 squared plus 10 squared minus 2 times 10 times 10 times cos of PBQ. Before I simplify this, I know that I'm going to need to work out what PQ is, and that's probably going to be in terms of x because our answer has an x in. I can see from my diagram that PQ is equal to AC, so if I work out the value of AC, then I can work out what PQ is. AC is its own triangle. It tells us the angle ABC is 30. It also gives us that AB and AC are both x. So to work out the length from A to C, we're going to use the cosine rule. We know that AC squared is going to be equal to x squared plus x squared minus 2 times x times by cos of 30. Okay, I can simplify that to get a value of AC squared. We should see that this is 2x squared minus 2x squared, and our value of cos 30 is root 3 over 2. You can see this is starting to come together because our answer has a root 3 in it as well. Simplifying this, we end up with 2x squared minus root 3 lots of x squared, and if I factor an x squared out, this is x squared and 2 minus root 3. Note that I've kept this as AC squared. I haven't worked out what AC is because in our answer we need PQ squared rather than just PQ. So I'd have to square root it to square it again, which doesn't seem sensible. So PQ squared is going to be x squared times 2 minus root 3, and that is equal to 200 minus 200 cos of PBQ. Rearranging this, we can see that cos of PBQ is going to be equal to 200 minus x squared times 2 root 3, all divided by 200. If I divide each term individually by 200, we get cos of PBQ is 1 minus 2 minus root 3 over 200 x squared, and that is proven. If you found this video helpful, please do consider subscribing. It does make a big difference. More walkthroughs and exam tips are coming soon. Any suggestions, please leave it in the comments. Thank you for watching.